Okay, this question is 4.125, and this is a calculator question basically. About the only thing you can do as far as by hand is you know this is y is equal to x to the third power, and you know you have a y-intercept of -10. There's the y-intercept. And this tells you the end behavior is going to look something like this, opposite directions. Okay, if it was if the leading exponent was even, it would be the same directions. X to the fourth squared, x to the fourth, x to the sixth. It would have ending behavior going in the same direction. Okay, I don't know what's wrong with this. There. Okay. It would have it going in the same direction. So the ending behavior, and I'm just going to draw a graph by hand. The only thing you can do is -10 like that, and maybe it looks something, I don't know, like that. That's the only thing that you can tell by hand. Now, plotting, if you didn't have a calculator, you would have to plot several points, and that would be very, very tedious. You would have to do it by hand, and because you don't have a calculator, you would pick like -2, or I would pick like x, y, -10, -5, 0, 5, and 10, because you have nothing really to go by. So I would just pick, and why wouldn't you pick -2 and -1? Because it might be too small and you won't have a very good graph. So that's why I kind of spread the x out. Now, what do you do with this problem since it is a calculator-based problem? You basically do it on a calculator. All right? You take your calculator and pull it up. Well, I'm trying to pull mine up. There we go. And I'm going to move it over if it'll let me. It probably won't let me. And I'm going to hit... See, it's going to go on, and I'm going to hit clear, and I'm going to hit y is equal to 1/3, and this is going to be very difficult. Let me go over here to my try it again. Okay, I'm going to type in parentheses 1 divided by 3, close parentheses, x to the third power, okay, and then I'm going to say minus, parentheses, 5 divided by 2, close parentheses, x to the second power, plus 6x minus 10. And then I'm going to hit graph. Now, it may not show up the first graph. Yep, there it is. Now, the window is telling you basically how do you want to look at this. All right? I tell students to hit zoom, standard, 6. I tell students to hit zoom fit. Zoom fit, I think, is on down. Zoom fit is 0. Hit enter. Well, you got to bring it up a little bit. Hit enter for zoom 0, zoom fit, and it'll put it in the window to make sure you hear it. I also use zoom window or zoom box. I do that also. I see that's a little bit closer. You see the y and the x intercepts. Okay, I go to zoom box, and I put the left-hand corner. I move it. You'll see the x in just a minute when I move it. See that little cursor? I make that the left-hand corner right in there. And I hit enter. And then I draw a box around what I want to see. Just like if you was to drag a mouse. Okay? Just right in there. And then I hit enter. And then that just draws that section. So this is a calculator drill. And of course, if you want to do window, you would hit window, and let's say I want to do my x min to be -10. My yx max, don't use the keyboard, Hubert. I'm sorry, hold on. Window, I got to use the keyboard on here. -10, and then 10. And then let's say, we know our y-intercept is -10, so I'm just going to put -50 here. And my y-max, 100. And then hit enter. And hit graph. And now the window is set to my parameters. And that's how you use Windows. So they're trying to find the best one. And it looks like to me that the best one is probably that -10, which would be B, because that would have a good solid, it'd have a Y min of -10, a Y max of 10, an X min of -10, and a Y max, and that'd give you a good picture. But you can use Zoom Fit, you can use Zoom Standard, you can use Zoom Box, or you can use the window to set your parameters for the graph. Okay? Hope that worked. Oops, it's not right. Then I guess 0. I don't know which one. Nope, they say it's C. Okay. It's preference. It's whatever you want to use, but evidently they're using 0, 5 by -6 and 4. I don't agree with that, but. And the local min, max, how do you use that? Well, you go over here and you hit second, trace, and find the min. That's number 3. And then you don't have to do left bound or right bound, but you can if you want to. My min is basically where it's turning. It's got hidden behavior, I think. So we're going to have to go on in because it's got hidden behavior. Let me zoom on in because you need to see that hidden behavior. So I'm going to zoom in even further, box. And hidden behavior is what you see after you blow it up. So I'm going to blow it up even more, and I'm going to make it a little bit smaller. I'm going to just get the y-intercept in, and then I'm going to just get the x-intercept. So I'm making my windows smaller, and you're going to see the hidden behavior. See, now you see going up, and then you see, so, you know, you gotta turn here, and then you gotta turn here. Okay, so the local min would probably be this point over here. This would be the local max. You need to blow it up even more because you don't see the hidden behavior. I'm gonna leave out the x and y intercepts now. And I'm just going to blow up the section of bins. Hold on a second, I'm sorry. Zoom, box. And I'm going to hit enter right in here. And I'm going to make the box. There's nothing more frustrating than working with this calculator on the screen. So y'all just have to bear with me. And I'm just going to cover the bends, B-E-N-D-S, wherever it bends, and not worry about the X and Y intercept. Go again. Sometimes the calculator is a good thing, and sometimes it is a pain. So hopefully I'm going to cover the bins now. There's the bins. And I'm going to hit enter. Okay, now you can see the hidden behavior. And it took 3 times. What is the hidden behavior? Well, at the beginning of the problem, it looked like it was just doing this. Okay, but now that you've got it blown up, you see a max right there that goes up like a mountaintop, and then you've got a min right here, which is like a valley. So this is your local max. Okay, this thing is not working. Local max because it's the highest point, and then it goes down to a local min. Now, if you want to find those 2 points, then you hit second calculate, or I meant second trace. So I'm going to hit second. Second trace, and I'm going to find the min, which is your 3. So I'm going to go down and hit 3, or you can hit the letter 3, or number 3, sorry. And then I'm going to go over to the right side, because that's my local min, and I'm going to hit the left side, which is right there, and I'm going to hit the right side, which is right there. And all that does is tell the calculator where to look. Okay, write down, enter. And guess, I'm going to put a guess right about there. And there is the local min at 3. 3 and whatever that comes out to be. Hold on a second, I'll erase all this. So your local min is at 3 and -5, or 5.5. And then your local max, you do a second trace, and then max, and then you move over here, and you do a left bound, and it doesn't matter where you put it, as long as, see, right in here, right in there is the max, right in there somewhere. So I'm going to go over here where you actually see it going down, and I'm going to put enter, and then I'm going to go over here where you actually see it going down, and I'm going to put enter, and all that does is just minimize the calculation time for the calculator. And then I'm going to put a guess, which is right in here. And our max, our local max, is 2 and -5.3. So I don't know what this said, but that's how you do that. So I done forgot what it was. The local min point. I'm gonna just put 3. Y'all saw where I got it. I'm not gonna put the answer because I'm just gonna see what else this question asks. There's our correct. That's what we said. 2 and -5.3. Local min. I got it backwards. So, and check all. And there's 3 and -5.5. We got both of those. And that's what it's going to ask. It's going to ask for you to draw the graph. This right here, again, the window setting is up to you. Now, in this question, they wanted you to use this one. In other words, blow it up so you can actually see the hidden behavior, which the hidden behavior, you have to blow this section up right here to see the hidden behavior, because you see it kind of looks level there, but actually the more you blow it up, the more it's going to look like that. And then this is the local max. And this is the local min. And a lot of people say, well, Hubert, what's the difference between a min and a local min? Well, local means that there is a local max and a local min. This would be a max. In other words, there is no other term, okay? If you have a maximum, and that's it, or a minimum, and that's it, then you have a max and a min. But if you don't have a max and a min, then the next best thing is a local max and a local min, which means you have a term. Okay? So, on this question, 1, you can do a little bit by hand, but that's the only thing you can do by hand is say, okay, the hidden behavior looks like this, because it's a cube, it's an odd function, and it's going to cross at -10, so it's going to look something like that. That's the only thing you can do by hand. The rest of this is done on the calculator. So I hope that helps, and let me know if you have any more questions.